Hello, good evening guys, welcome back to the video. And in today's video we are back with the part 2 of the solids. This is a part 2 of the solid series, and today we are discussing the types of solid. While in the previous video we are done with the introduction to the solids, and if you haven't checked out that video, do check it out from our playlist. uh, Yesterday we did an overview of solids, and to make the concept clear, the concept, you must watch the part 1. In today's video we have got the part 2 in which we're discussing the types of solid, and particularly if we talk about the types of solids, so we've got two different types, the crystalline solid and the amorphous solid. But in today's video we're discussing the crystalline form. In the next video sorry in in the next video probably we are discussing the crystalline form, while in this video we are discussing the crystalline form, while in the next video probably we'll look into the amorphous form. I will just look into clearing the concepts. So I've got beautiful diagrams, and with the help of theory and practical, both sides I will be clearing you, and we're looking into MCQs and the basic actual concepts behind it. First of all, as I discussed before, that solid is a state of matter. There are two main types. One is a crystalline, one is amorphous. We will be discussing what does crystalline mean and what does we are not going into amorphous right now, but you can think that the crystalline opposite is amorphous, right? We will having a complete different video for amorphous. Now let's start without wasting time. The crystalline solids. Okay. uh, Sorry, here, crystalline solids. Now, in the first point it is written, same lattice can be used to describe many different designs. Now this is very important. You will hear this in crystalline solids again and again. uh, I'm highlighting the word, uh, the same lattice. Same lattice is very very important. Probably we'll be having a video on the what is lattice. For now you can understand the arrangement of atoms throughout the crystal is termed as lattice. We can say that that is crystal lattice. We'll be having a particular video for that, but right now you can say that the arrangement of the atoms present in a solid is termed as its lattice. We can say that the network of atoms is termed as the lattice, or the crystal lattice or the solid lattice. Now here is the point, that is there in the crystalline solid there is always the same lattice. What does that mean? There is a uniform, you're gonna see a diagram over here. We have got this one line, then 3, then 2, and then 1. Again on this side we have got 3, 2, and then 1. There is the same, same lattice is there on the both right and left side. In the center we have got 5 atoms, then 3, then 2, then 1. On the both sides it is the same. This is the crystalline solid. uh, there is regular arrangement, like on the side you're gonna find 3, on this side you're gonna find the same. Now you're gonna see that between uh, surrounding each atom there is uh, how many, this one, this dot present 1 and 2 and 3 and 4. The same is everywhere else, and these all are arranged in a way that chlorine is the bigger molecule, while sodium is in the mid between the both. Okay, this is chlorine, sorry, and this is a sodium, right? Sodium is between. This is a particular arrangement. You will understand by looking into more diagrams. Again, you will see face centered cubic unit cell. Now when you open this, a single part of this, you will find that there's, if you have taken out a cube, you'll find that there is a particular geometry, like the shapes are all interconnected and are just repeating throughout the crystal. uh, let's move forward, probably you will understand it shortly. For designs based on, uh, you know uh, we'll talking about unit cell in detail in our upcoming video probably, but do remember that this whole system, in this one, we can say that one unit is termed as a unit cell. I'm not going in detail right now, but the the smallest part of lattice crystal lattice termed as a unit cell, and the unit cell is repeated again and again in a particular way in a crystal. Okay, there are empty spaces, there are edge lengths, but these are all equal and all calculated throughout the crystal. The only requirement is that the same design element must be associated with each lattice point. I have just told that each around each chlorine we have got 4 sodium in this diagram. So this is again saying the same, that we have got must associate with each lattice point same design. So this is hence proved. This is a property of a crystal. Here is pointed in chlorine ICIC associated with the lattice point and FCC unit cell. What we're discussing this in our next video probably. The sodium ions are placed between the chloride ions. Yes, there is a particular arrangement, and I have told you that before. Now move to this diagram. You're gonna see in this diagram that here is again a particular arrangement. You're gonna not see. You're gonna see that hexagonal rings are there. Probably they are hexagonal. So these are repeated again and again. This is not like one is circle, one is square, and all that. That would be not a lattice, crystal lattice. That would be not a uniform arrangement. Here you're gonna see that you know see that the particular geometry is present in the crystalline solid, and in amorphous you're gonna see. Now, I was not talking about amorphous, but this diagram has told me to give you an idea about what amorphous is. You're gonna see that in crystalline SiO2 quartz, what is this? You're gonna see particular geometry, but if you're gonna zoom into it, this is not the same. You're gonna see that this is the first shape, and this is the second shape. Probably I'm changing the marker to make it more clear. Uh, this is the first shape, right, and this is the second shape, right. In this you will see that this is the first shape and this is the second shape. Now there is a clear difference in the crystalline form. There is particular geometry, all the spaces are equal, all the lengths are equal, all the atoms connected are equal, but in the amorphous that is not the same. So I hope that this picture will help you a lot to understand the concept. Let's move forward. First of all, with the from moving through this typical diagram, first move this one simple diagram, and again you're going to see particles in this format. Table salt, you're going to see that this pieces of the when you will zoom into a microscope, then you will find that they have got particular arrangement. That is the reason they are in a form of crystal. When we will hammer it, you will find that they are still in the same form. We will talking about these properties of a crystalline solid probably in our upcoming videos, while this is also an important diagram, but I will be not going in that much detail. This topic is coming in our upcoming videos. I'm just giving you overview that types of crystalline solids. So we have got molecular, we've got covalent, we have got ionic, and we have got metallic. Now this is characterized on the basis of the bondings which they do have. If they have got molecular arrangement, like they have got two different molecules, they are attaching by van der Waals forces. So that is the molecular. And we have got covalent, so they have got covalent bonds. We have got ionic, we have electrostatic attractions. Metallic, we have got metallic bonds. I'll be talking this picture again in our upcoming videos when we will discuss the crystalline solid in more detail. While I would like to tell you a point over here. You're gonna say that the particles of the crystalline solid are arranged on the axis x, y, and z axis, and there is a regular arrangement. Particles arranged in definite directions. They have got sharp melting point. Uh, there is a concept over here, very important concept, that let me take this one diagram. You're gonna see that when you will give heat to this amorphous form, and then we will give heat to this the crystalline form. Now they have got equal. Everything is equal. Every arrangement, every length, every bond. So they will have a particular melting point. Sorry, while the amorphous will have for suppose this smaller unit will 56 degree, 51 degree, and this will burn at 100 degree. So there is a difference, but this will have the same. This is 50 degree, so this would be 50 degree, because they have got sharp melting point. They have got sharp melting point. and they have got a range of melting points. There is no particular, like some may melt, some is remaining, and that would be not properly we discussing in the amorphous video. And there are different forms of crystalline substance. A single sorry, a single element can have different crystalline forms. We'll talking that in our upcoming videos in detail. Okay, I do hope that you've got the concept, and we have talked about the crystalline solid, and I do hope that you've got the concept. Meet you guys in the next video. Till then, goodbye.